everyone. Welcome to our monthly Kube Chat. Today's topic is the hidden cost of idle Kubernetes resources and what to do about it. So digging right in here, I'll move on to the agenda for today. So we'll be starting with a quick overview of idle resources in Kubernetes and why they matter. And then from there, we're going to define some of the primary drivers that can contribute to this inefficiency. Next, we'll dive into some strategies that you can use to start reclaiming some of the efficiency in some of the primary drivers that we cover. And then we're also going to talk about some continuous monitoring and how you can keep those costs from creeping back in. And then we'll also wrap up with some Q&A at the end. So feel free to submit questions in the Q&A feature of your console there, and we'll cover as many as we can. I also wanted to flag that we'll be recording today's webinar. So if you cannot stay for the whole thing, we will be sending you a link to the recording within a day or two. So be on the lookout for that. On your console, you'll also find a link to download a PDF version of today's deck. So you can follow along and click on some of the links that we've included throughout. But you'll also find a link to our monthly Kube Chats landing page where you can find all of the webinars that we have hosted in this series over the past couple of years. And you'll also see a link to our October webinar, which is going to be all about Kubecost 3.0, which is actually launching next week. So if you'd like to learn more about all of the great new features we'll be launching with 3.0, feel free to join that webinar. We'll be doing a deep dive on everything. So moving on to our speakers. First, we have Joe. He is a principal product marketing manager here at Kubecost. He's been leading go-to-market efforts across cybersecurity, cloud, fintech, edtech, and he's shipped millions of products used by millions of customers. Today, he helps organizations get visibility into their Kubernetes costs and just make smarter efficiency decisions. So he'll be walking us through some of those strategies that you can do today. And if you'd like to keep the conversation going, feel free to connect with him on LinkedIn, and he'd be more than happy to chat with you. Our second speaker for today is Mike Riggs, and he is our senior solutions engineer here at Kubecost. Mike has over 25 years of experience delivering enterprise solutions across telecom, big data, and cloud native ecosystems. And today he helps organizations optimize their Kubernetes environments for efficiency and operational resilience. And he'll also be digging into details of some of those primary drivers for tracking idle costs and how you can overcome them today. If you'd like to connect with Mike, you can also find his LinkedIn there. And with that, I will pass it over to Joe.
Thanks, Dee. Hi, everybody. Thanks for joining us today. If you're new to Kubecost, this will be your orientation slide. IBM Kubecost is built to help you with real-time cost visibility, real-time cost insights for your Kubernetes environments. It's used by teams using Kubernetes from cloud native startups all the way up to the largest enterprise organizations you've ever heard of. And it helps them to understand their Kubernetes costs and continually reduce those costs without sacrificing things like performance or stability. It runs on any Kubernetes environment, whether that's AKS, EKS, GKE, on Red Hat, OpenShift, air-gapped, brewed at-home Kubernetes that you've spun up yourself. And across all of those environments, on behalf of our customers, we're managing more than $5 billion in Kubernetes and cloud spend. We're a global organization with teams all over the world to help you continually reduce your Kubernetes costs and be successful in gaining efficiencies there. Some of the companies that entrust us to partner with them for that are Johnson & Johnson, Audi, GitLab, EA, and others. With that, we'll jump right on into our presentation today. Cloud waste is this huge problem. In fact, about 90% of the customers that we talk to find that for every dollar that they're spending, somewhere between 30 and 50 cents of that is going towards idle or over-provisioned, wasteful spend, right? These are dollars that are just floating up into the cloud and not providing any kind of business value to you. Idle resources don't necessarily hurt performance. And so because of that, they can stay hidden right all the way up until the bill arrives, all the way up until you close the budgeting cycle for the period and you find that you've overrun those budgets. The bill is bigger than you thought it was. It is once again up and to the right. I don't know about you guys, but every company that we're talking to today seems hyper focused on saving money, on doing more with less, on being more efficient, on not being wasteful. I think it is, it is the theme of our time right now. Every dollar of waste is under scrutiny, and every dollar of waste can contribute to having a project that you're really invested in, that you want to work on, that's fun, that's challenging, that's necessary, being defunded and a pause putting on it, or having to perhaps deal with fewer engineers on your team than you would like to, and not having the resources that you need, right? The implications of waste in cloud spend and in Kubernetes spend really can come down to things like whether a project goes forward or not, whether you hire an additional resource, or whether you're able to keep working with your colleagues. So the stakes are pretty high. Kubernetes isn't malicious, it's complex. And so it is really good at masking inefficiency. Things like pods and nodes can look healthy, they can look properly configured, but they might have a lot of wasted capacity that is just sapping your budgets. Our goal today is to show you where some of these idle resources often hide, how you can gain visibility and start to measure them, and then ultimately how you can take some action and do the fun stuff, which is getting rid of that waste, increasing your efficiency, saving money out of your budget, your team's budget, your department's budget, your organization's budget. And that's good for everything and everybody. Let's start figuring out where these things hide. So Kubernetes clusters are usually going to have hidden wasted spend in one of these three main areas, right? They're either going to be hiding in an over-provisioned pods, in underutilized nodes, or in over-provisioned storage. When it comes to pods, right, this is going to be containers that are requesting a lot more CPU or memory than they ever use, even at their peakiest, most consumptive periods of time. And that's going to leave some reserved capacity that is going to create idle, and because it's going to still ring up the cash register and cost you money to have it, that contributes to waste. At the node level, right, worker nodes run at pretty low utilization, and cloud providers charge full price, whether they're busy or not, whether they're performing at a level of efficiency based on what's being requested versus what their capacity is, right? So remember that you're paying full boogie for those, regardless of how much they're being utilized or utilized at all. And then this last kind of area, over-provisioned storage or oversized persistent volumes, those things also keep billing, even when the workloads that we're utilizing them are long gone. And these are the types of things that don't necessarily just clean themselves up when you decide to destroy a cluster, or get rid of the core components of an environment. So it's these three buckets that are going to account for most of your hidden Kubernetes waste. Each one of these can be tracked with visibility, and you can gain that visibility through open source and free tools like Opencost, like Kubecost Foundations, which is free to use, or with one of the enterprise solutions that Kubecost provides. Let's go ahead and go to the next. Mike, handing it off to you. We can dig a little deeper on those three buckets.
Thanks, Joe. Appreciate it. So as Joe mentioned, what I want to do is we're going to dig a little deeper into those three problem children, if you will. And then what I want to do is we'll look then at some tools that exist in terms of how to help remediate some of this. We're also going to take a little look at how Kubecost can help with some of that as well. So I'm going to start with over-provisioned pods. We're going to kind of go through these in the order that Joe mentioned them. And this is real. This is a real problem. We talk to teams daily that have no idea what's going on in their environment in terms of what resources are being consumed. Developers want to develop their work. They want to deploy their workloads and make sure that they've got the resources to make sure that their workloads are doing what they need to do. And they're not always going to be really concerned about cost or about saving resources. So in this example that we've got here, we've got, for example, this one, I've deployed a workload in this top one, CPU usage. I've got this one over provisioned for both memory and CPU. And what we see in both of these graphs is the bottom line, the green one in both cases, is going to be kind of that kind of baseline of those resources, and the top, the orange one on the CPU one, and then the blue line in the memory chart represents that resource wastage that is driven by over provisioning both CPU and memory. And what happens is these, as these things kind of move up in lockstep, and this is going to trigger things like if I've got cluster autoscalers turned on, we're going to start spinning up extra nodes. We're going to start incurring additional costs. What we see is this kind of gap right here typically is 30 to 50% of that wasted cloud spend. And the first kind of step here is get visibility into this. How do I know that this is occurring? What tooling exists so I can not only understand what's going on here, but then go take steps to fix that as well. The next thing, don't talk about, whoops, oh, we got a little, okay, there we go. Underutilized nodes. And so underutilized nodes is going to be this, in this graph I've got here. The idea is that I've deployed these workloads that are consuming some resources, but they're not consuming all the resources that a node has available to it. And so, for example, in these examples here, or in my example drawing here, I've got a node with 32 cores. We're only running at about 62-ish% capacity here. And what happens is, this is driven by things like uneven bin packing, instances that are oversized, or sometimes we even see workloads, as workloads get scaled down, those nodes then are just free. They're just out there, just idling, not really doing much. And your cloud service providers don't always, they prefer that you let those resources continue to run, even if they're not properly scaled. So what we see here then is a combination of things like we're not tight enough bin packing the nodes, instances that are too big, and then workloads that scale down and just let these left nodes kind of in this sort of abandoned state. And again, the idea here is, how do I get visibility into this stuff? How do I understand where this is going on in my environment? Again, first step, visibility, and then we'll talk about kind of how we go about remediating some of this stuff. So next up then on the list is going to be over-provisioned storage. This one I like. This is one where this is a challenge. This is really, really difficult to understand. So the old mantra is storage is cheap. Go at it. Go deploy what you're going to deploy. But there is still a lot of opportunity for wastage here. It's a black box. When I go deploy volumes, it's very, very difficult to understand. Are there volumes that are provisioned that are not being used? Are there volumes that are over provisioned? Do I have something going on that I need to go, again, take a look at? I need visibility into this issue. Cloud providers are going to bill you based on that, if that storage is used or not. So you can have this unused storage sitting out there, incurring costs, that this little silent cost adder to your cloud bill. And again, visibility is challenging for these things. So we want to then kind of start looking for things like low efficiency workloads that we've got storage that's way over provisioned. Again, back to those efficiency things, and how do I go resolve these? So we've kind of a little bit of an understanding then of these kind of three key places where we see wastage, and all three of these they're hard to see. They're just, visibility into these things it's just difficult. So towards that, let's take a look then. Actually, I believe that's yours, Joe. I'll let you. I'll let you go up, talk about this for a second.
Thanks. Look, up until this point, we've looked at where these costs are hiding. They hide in pods and nodes and storage, right? And that's visibility. As you start to track these things, it starts to maybe look more like observability if you're doing it on a continual basis. But the next step, right, the thing that gets us over the bridge and to this fun part where we can actually start to optimize and start to save some money and increase our efficiencies and become accountable as an engineering group and all of the great things that we have goals for ourselves for, we need to take measure, right? We need to do some measurement. We need to turn things like these this data, these inefficiencies, into things like efficiency scores. Instead of identifying that we have some over-provisioned or some wasteful resources, we need to assign costs and numbers to those things. That's going to help us do a couple of things. Number one, it's going to help you to identify where the problem really is, right? Heat map style. I have, and I'm sure you have, limited time, only 2 arms and hands. There's only so much that I can do on a daily basis. There's only so much that my team can do. We are limited in those resources, so I have to pick my battles. It doesn't make a lot of time to chase optimization opportunities that are really high risk for really low savings trade-off. In fact, you should be plucking the low-hanging fruit very early, making that kind of muscle memory and habit, and then looking for other opportunities that should be prioritized for optimization. But once you translate things like idle resource numbers into actual dollars, it gets easier to align teams around things like who owns this, who's responsible for determining how to improve this, who's the team, what app is it, what namespace, what cluster, figuring out how to get teams, especially when those teams come from different departments and have to work cross-functionally, to kind of band together and justify the next body of work that has to happen, which is taking action through optimization. It's this measurement that helps put a source of truth in numbers in front of everybody and can get those teams, as different as their goals may be, to align around the next step that has to happen. So this is that bridge, right? Visibility into measurement into action. And so I'm going to give it back to Mike now. We'll dig into some of the strategies that you can use to reclaim your efficiency, kill that waste off.
Cool. Whoops. There we go. All right. So thanks, Joe. And what I want to do is we're going to talk for a little bit about some of the tooling that exists for each one of these types of scenarios, and then we're going to talk a little bit about also how Kubecost can help with that too. For the first one, for optimizing over-provisioned pods, there's Kubernetes have a bunch of native built-in tools. We've got things like the horizontal pod autoscaler. So what the HPA is going to do is, as that workload scales up, we're going to add additional pods into the mix to account for that workload. The vertical pod autoscaler is another tool kind of at your disposal there. That one is going to then reallocate resources to a pod so it can increase the resources available to that pod. And then finally, we've got the cluster autoscaler, which will then go add nodes to the cluster as those workloads scale up. So we've got tools that are available, kind of tools in the in the toolbox. So then beyond that, what else can we do here? And so the idea is I want to provision my workloads so that they have sufficient CPU and sufficient memory to do what they need to do, but I don't want to leave a lot of excess memory and CPU out there that's not being consumed. So the first thing we want to do is look at right-sizing those resource requests. And there's any number of open source tools out there. For the purposes of what we're looking at today, I'm gonna lean on Kubecost. This is available in the community edition Kubecost, or Joe, I think we're calling it a different name now. Did I hear that right?
Foundations, Kubecost Foundations.
Foundations. Yeah. There it is. Okay. We gotta have a new name for things. So Kubecost Foundations. So what I want to show y'all is available in the Foundations version of Kubecost. So this is, again, free open source tool that's available to help identify this stuff. So the first thing, right size resource request. I can then go look at, again, the tool I'm going to look at is going to be Kubecost, but the idea is I've got my resource request, I'm consuming these resources, am I requesting stuff that is not getting used, CPU and memory that is not being used? So the first thing we can do is kind of refactor those workloads to make them more efficient. And then the next thing that we see a lot of, and this is really common, especially in development type of environments, things like I'm out testing my workloads, I've deployed a bunch of test objects, bunch of resources, and it may be that, and we see this often, again, development environments, something comes up, I've got to go put out a fire, and I kind of forget about what I've got going on over here. So we see a lot of abandoned workloads, a lot of test workloads, a lot of jobs have been forgotten, very much in sometimes in production environments, but very often in development environments. So the next thing then is let's go identify those workloads and clean those up. And then we talked a little bit about these autoscalers. So where my usage fluctuates, where I've got workloads that are scaling up and down, employ these tools, these things that are that are built into Kubernetes, the HPA, the VPA, the cluster autoscaler. So those are things that we can use to address that issue as well. And then the other thing is we want to continuously be able to audit the efficiency. And Joe brought this up, efficiency being the idea of, am I consuming an adequate percentage of the resources that I'm requesting? So we want to be able to continuously audit those efficiency scores to make sure that once I've gone to the trouble of rescaling, reshaping my workloads, that they stay that way. Okay. The next thing we talk about here is kind of where Kubecost fits into this deal. Kubecost, there's a panel in Kubecost that we call container request right sizing recommendations, and this is a representative screenshot of it here. And what we're looking at here, and you can see in this graphic, there are some black bars and blue ones and green ones. Those represent resources that are appropriately provisioned. But where we see these kind of light gray bars, this is going to represent resources that are over provisioned. We have an efficiency score out there that goes with that. This is kind of that idea of I want to go and audit these to make sure that my scores, my workloads are still as efficient as they were when I provisioned them. And so we can highlight workloads that are over provisioned. From here, there are a couple of things that we can apply to this. So there's a button up there that says production, kind of top left corner of the screenshot. That lets me optimize my workloads according to particular environments. So prod environment's probably going to be optimized different from a dev environment. So you've got ways that you can adjust the types of optimizing based on the environment, based on what's appropriate for that environment. So what we do here is we identify these sources of wastage, and then Kubecost from here can continuously right-size certain types of workloads. So some of that can be automated. We can also put these values, for example, as part of my GitOps workflow. I can put these values in my source of truth, deploy these workloads, and then I'll have these workloads out there running a little bit more efficiently. But the idea here is Kubecost is one of those tools. There's a bunch of tools that are built into Kubernetes we can use, but there are additional tools out there, tools in the toolbox that can make this a little bit easier to deal with, a little bit easier to work with in terms of understanding where can I go right size those resources to make them more efficient, less expensive. Okay. The next one we're going to talk about is going to be, find my underutilized nodes. Underutilized nodes can come away, they tend to show up as a result of some of the stuff we've talked about before. I've downsized some workloads and now I've got nodes out there that aren't being used to their full capacity. I've perhaps deployed workloads that are over provisioned, so now I'm basically consuming more resources in that node that are necessary. But in general, it means that we're paying for capacity that's not being used. It's just sitting there idle. It represents wasted spend. So we've talked a little bit already about enable the autoscalers. Those can kind of help with these things. The other thing we can look at is right-sizing those nodes. So perhaps I don't need the biggest nodes that are out there. I can probably get by with some smaller nodes. If I've got nodes, for example, that maybe have GPU capacity and I'm not using that, that's another example of those nodes can be replaced with more appropriately sized nodes. We can use schedulers then, so we can more tightly bin pack these nodes. And we can use things that are out there. Spot instances are a good way to then lower costs. And then you want to kind of keep an eye on, again, the metrics so that we don't keep having this persistent underutilization problem that keeps popping back up. And so we want to kind of catch this situation before it spirals up, increase costs even more. So this little graphic that we've got here kind of shows that journey from left to right. So on the left-hand side, we've got these nodes that have a bunch of wasted headroom on them. The one in the middle there, so now my application is right-sized, but that node could probably be downsized. That node is just a little bit too big for that right-sized workload. And then on the right-hand side, that's going to be kind of your optimal sort of situation where my nodes are appropriately sized, my workloads are more efficiently packed, and this gets us past that problem of underutilized nodes. And you may be surprised to find out that Kubecost can play a role here too. For these, node efficiency, there is a view in Kubecost that we call efficiency score, and it's exactly that. I can go and look at these efficiency scores. We categorize idle cost in different kind of buckets, if you will. So in terms of memory, CPU, GPU, so we can understand then, are these workloads, you'll see a figure out there, all these idle costs represent wasted cloud spend. So we categorize them in different ways. We can then go take a look at my nodes that are maybe less efficient than others. I've got some here that are looking pretty good, and then some that I probably want to go take a closer look at. But the idea here is these are, again, this is difficult information to get from your billing data, from your cloud consoles. But this is actionable information that you can use to then go start looking at right sizing these nodes. We can also look at savings opportunities. So all of these numbers here where we see idle figures, these represent savings opportunities. Kubecost also can track this over time. So I want to go look at what my workloads look like, next week versus the previous week. We can go do that, and so that we can understand what those trends are looking like. So for node efficiency, again, we've got this. Oops, apologies, I'm clicking the wrong thing here. There we go. For node efficiency, then again, this is a common driver of wasted spend. You're paying full price for these nodes, regardless of how much is being used. And it's not a short-term thing. Kubernetes workloads are going to fluctuate up and down over time. So this is another one where you want to kind of keep track of those metrics and keep an eye on these over time so you can understand, are my trends increasing, decreasing? It's a metric to be tracked. So you can kind of follow that along to make sure that we're not getting back in that situation where I've got a bunch of underutilized nodes. Next up, let's talk about storage. Storage, I mentioned this earlier when I talked about it the first time. This is one. So when we're sitting down and talking to customers and we're kind of going through some of the value that Kubecost provides, this one's always an eye opener. Teams look at this and we can show them where they've got volumes that are just wildly over provisioned. And, again, the mantra is storage is cheap, but it adds up. There are a lot of these, even my little demo environment, I've got a little tiny little demo environment that I've got tons of wasted space in. And it's the same thing. It's difficult to identify this. It's a challenge to pick this information out of your billing data, or even, again, out of your other tooling. So the first kind of thing we want to start looking at is getting rid of orphan PVs. If I've got resources that have been orphaned, there's nothing using them anymore, then again, you're paying full price for those PVs if they're being used or not. We can also look at over allocated storage. We touched on that again a little bit earlier. If I have storage, if I've got volumes that are provisioned and they're just not even close to being consumed, again, you're paying full price for that. Doesn't matter how much of that's being used. The last couple of things that we can look at then, things like snapshots, backups, unattached disks. You've got most teams are going to have some sort of data retention policy, and oftentimes things like snapshots, backups, unattached disks will kind of slip through those cracks, and now you've got, again, this problem with storage that's basically wasted cost. So the next kind of thing we look at then is go audit the snapshots, take a look at your backups, go see if you've got any unattached disks that are out there just quietly racking up your cloud bill. And this is another one where you want to kind of keep track of these metrics over time because, again, dynamic environment, these things are going to change. They're going to go up and down. You want to regularly monitor and clean these things up. Again, Kubecost can help with this. There is another section in Kubecost in the savings section where we can identify things like orphan resources and persistent volumes that are over provisioned. The orphan resources that we're identifying that you kind of see in that little graphic in the background there, Those are going to be disks that are not being used. They're going to be persistent volumes. They're going to be IP addresses, so public IP space. Maybe I've exposed a workload on a load balancer on public IP. That workload's gone away. I'm still paying for that public IP space. That's a resource that's been orphaned. We can probably clean that up and go realize some measure of savings. The slide, the kind of little graphic that gets closer up in the foreground there, this is where we're identifying persistent volumes that have been over-provisioned. And it was kind of hard to squeeze that in there. It's a little difficult to read, but you can see that, for example, that top one up there, I've got provisioned at 500 gigs. It's being used at about a little less than 17. So we can see there, my current cost is $40, but if I were to resize that, that volume to something a little more appropriate, that I can save the bulk of that $40 cost. So again, the idea here is Kubecost can help you identify those resources. You can resize these. We can delete things that are not being used. These can be sorted out and kind of visualized. We can look at these by namespaces, by teams, by different workloads. There's a lot of different ways you can aggregate, kind of sort the data to get at it, what it is that you're looking at. But at the end of the day here, there are oftentimes, this is a black box. There are oftentimes, especially persistent volumes, this is always an eye opener when we're working with teams going through like a POV, POC type process. When we pull this one up, like eyebrows lift. It's pretty cool. And again, storage is cheap, but man, there's a lot of opportunity for savings there. And I think, if I'm not wrong, Joe, I believe the next one's all you.
I believe it is. Go ahead and advance that one there. So continuous monitoring, right? That's what prevents optimization from being this once a year whack-a-mole perennial pain in the rear that you do, and then you forgot that you did because it was so unpleasant, but then you have to do again, next spring, like deep cleaning or something like that. Staying on top of this, leveraging the observability and visibility tools of something like Kubecost is what's going to prevent this from having to painfully happen over and over and over again, where the problem gets really bad. People come banging on your doors asking, what is EKS? Why is it so expensive? Do we really need it? If you can stay on top of these costs, you get to write the ending of your own story in many ways, in terms of being able to focus, stay heads down, work on interesting, fun things like new features and capabilities, rather than reworking your applications and your infrastructure constantly to remediate waste. Things like dashboards are going to give you and your team a real-time finger on the pulse for things like cost and efficiency. You won't have to worry about tracking your, big anomalous, painful spend. You'll be able to break that up into smaller chunks and bits that you can deal with on a constant basis. And when people understand and have some degree of accountability for the costs that they're directly responsible for, you will find that you're racking up fewer and fewer of these big problems that have to be dealt with, on a non-constant basis. Setting up things like alerts, which Kubecost can absolutely help with, is going to help you surface spikes in idle costs. It's going to help you surface idle costs. It's going to bring your attention to big drops in efficiency before they snowball and turn into something that your boss's boss's boss finds out about, and then would like to have conversations and ask questions about. Things like scheduled reports and governance guardrails are going to help keep cost accountability not only visible, but occurring without it having to be baked into your everyday life and having to think about it, right? Engineers don't want to have to be compliance experts. They don't want to have to be security experts in many cases. They don't want to have to be, cost accountants and cost optimization specialists either. But being able to set up things like automated guardrails that might prevent a team from spinning up resources that would exceed their budget, or that don't fall in line with your platform team, your organizational or engineering policies around what should and can be used. And then, of course, reports that inform all of your cross-functional stakeholders about what costs are, what efficiencies are, how they're trending over time. That goes a long way in aligning teams, diffusing friction, getting people to work towards common goals. And continuous monitoring isn't just about observability, although that is a big part of it. It really comes down to accountability. DevOps engineers will do the right thing when they have the data and they have the resources to be able to make the right decision. So empower them with this visibility, with the data that they need. Work with them to measure, what the real situation is and where the priorities are, and then collaborate as a team to get rid of waste and operate more efficiently over time. You need these constant and actionable signals to be able to do it. Otherwise, you fall right back into kind of wasteful patterns and into a non-continuous process that always hurts every time it comes around. All right, go to the next slide here. So getting close to wrapping this up, continuous monitoring really is about keeping efficiency gains in place, not just kind of trying to fix waste once, but doing it all the time, continuously. That's how we turn this from, like a cleaning at the dentist instead of a root canal. Kubecost can make this a lot easier. We've got scheduled reports. We've got the ability to give this continuous visibility and cost and efficiency trends in ways that could be either UI-based, API-based, and fit into your development workflows, not disrupt it. We've got alerts that can help notify teams when things like idle costs spike, when efficiency plummets, when workloads suddenly overspend the budget criteria that you set for them, so you can catch these issues quickly instead of them showing up in the bill and becoming a hot topic. We have budgets in the tool that allow you to create this environment of accountability, whether it's at the namespace level or at the team level, the product level, the label level, right? There's tools there that let you kind of dice that into whatever business dimensions make sense for you and your team. And you then empower them to see how they're doing, how their spending tracks against team goals, individual goals in an application, or even on a cluster or environment layer. In the example here, you'll see a team budget view, and it shows the actual spend as of today in near real time, right? Refreshed every 10 seconds or so, versus what the established and set budget is. And this helps teams course correct long before they reach the end of that budget cycle, before they exceed that. So you're fixing it for this financial period, not trying to wait until next financial period to learn about what you spent and then course correct. With that, I think we've gotten to the end of our presentation here. There's some key takeaways that I'd love everybody to leave here with. Number one, idle resources are everywhere in Kubernetes, right? They are prevalent. Pods, nodes, storage, those things can quietly drain your pocketbook without adding any value to your engineering organization, to your business, or to your customers. So be careful with those. The first step is always to learn about them, right? Get some visibility. Observe those things. If you can't see an efficiency in your clusters, you can't act on it, right? If you can't get visibility into your Kubernetes costs, where do you even start? Once you have this visibility, though, optimization is where the real savings can happen. Right sizing, autoscaling, and cleaning up your resources to match the demand that they should align with. But that doesn't happen without this step of measurement, right? Understanding how much is this costing? What does the trend look like? Where is the waste? Uncovering and assigning values to those that the rest of the business can understand is that important middle step. Efficiency, once you get there, isn't a one and done thing. It requires continuous monitoring. It requires continuous measurement. It requires continuous optimization. Those things all have to work together for you to increase your efficiency and then keep it at an acceptable level to your org. Finally, efficiency sticks when there's accountability in place, right? We talk to customer after customer after customer and ask the questions. What is most helpful? What was the biggest change that you saw when you started doing things in a different, maybe better way? And it always comes back to accountability. If my team can't see that they're not doing it cost effectively, then they're going to continue doing it ineffectively, right? If they don't know that they're being wasteful, then they don't know that there's something that can be improved. But empower them with the tools, give them the data, give them resources that can help them to reduce that waste and become more efficient. And we find that constantly engineering teams are self-starters that want to do these things and be more accountable. That, I think, takes us into our Q&A.
Great. Thank you, Joe. So we got a couple pre-submitted questions and a few that are in the chat. We're going to start with one of the pre-submitted questions. So someone had asked if there was a way to view total resources available versus resources consumed in Kubecost.
There is. So what we have, there's a couple different ways you can kind of get at that information. It depends on how granular you want it and kind of what it is that you're looking for. But we have what we call an efficiency report, one of the panels in Kubecost, and we can go look at what that looks like on a per cluster basis, or on a per node basis, or on a per workload basis. So there are a number of different ways that you can approach that, but there is one of the newer features in Kubecost is this overall efficiency report, and you can see exactly that sort of information. Joe, I don't know if there's anything else you want to add or anything I missed there, but that's how I'll go about it.
Yeah, no, it's a huge amount of data. When there's too much data, right, it becomes overwhelming, and you can't really work with it or get much value out of it. So break it down into relative chunks and prioritize from there. So yeah, you can absolutely see these. It just might be a little bit of a data lake at a macro level. The next pre-submitted question, I think.
Yes, we're actually going to move over to the chat because we just got a question from Aaron Marino. So he wanted to know if there's a difference in Kubecost between on-prem versus cloud.
In terms of feature function? Oh, sorry, Joe.
No, all yours. Okay, in terms of feature functionality, yeah, no.
It's the same. The deployment method's a little bit different, but the feature functionality is exactly the same for both.
Yeah, really comes down to whether there's a impetus or a need for you to be able to self-manage and keep that entire solution behind your firewall. That might be because you're heavily regulated, like a financial services company or an air gap network with a government agency or something along those lines. Otherwise, there's feature parity there. It all comes down to who you want to handle the care and feeding of Kubecost.
Great. We had another question from Aaron that Joe actually answered directly offline, but I wanted to repeat it just for the visibility of everyone else on this call and anyone that might be watching the recording, because I think it's a good one. So on slide 15, we were showing a view of a dashboard in Kubecost that has efficiency scores at the node level. And Aaron called out that one of the nodes had an efficiency score of 324%, and he wanted to know if that was good or bad. So hoping we could cover that just so the full group can hear it as well.
It's not good. So effectively what that means is when we see workloads with a efficiency score over 100%, it means typically one or two things. That workload has either been under-provisioned, so it could be some danger of being evicted, or that workload has been deployed without any requests set, and it's out there just consuming what it's going to consume. But those two things will typically drive that score over 100%. But it's not an indicator that all is well.
Great, thank you. We just got another question too, where someone was asking, or actually they mentioned that they're an air-gapped environment. I wanted to know if Kubecost supports air-gapped environments.
Absolutely.
Yes.
So the difference here is in an air-gapped environment, or any environment really, where we don't want to necessarily, where you don't have a like a CSP API to talk to get the pricing basis. We're going to use a CSV file as the cost basis for those resources in that environment. And then from there, everything else in Kubecost will work pretty much just like it will for a public cloud. But absolutely supported.
Great. And we'll go ahead and wrap it up with one of our last questions today. So this was a pre-submitted question, and I saved the best for last. Someone wanted to know if we could give a sneak peek of the roadmap that was planned for the 3 products that fall within IBM's FinOps suite, which includes Cloudability, Kubecost, and Turbonomic.
Yeah, and I can speak certainly to the Kubecost aspect of it. We're the newest addition to the IBM FinOps family. And really for us, it's about integration. There is such a greater solution that is available to teams as these 3 products begin to talk to each other more, become more tightly integrated, provide a more seamless kind of experience for users. It becomes this kind of single workbench of an experience. That is the roadmap, right? And I think we've already seen some significant steps towards that. We have integrations with Turbonomic, where there are new automated optimization actions that are available to customers of both Turbonomic and Kubecost, and they're surfaced right in the Kubecost UI as savings cards. That makes a really nice experience to be able to see what the cost impact is of Turbonomic's right sizing and optimization actions, right? How do I assign like real value to what Turbo is doing for me in an automated way? I show how much money it's saving, right? So those 2 things I think are highly complementary and are a good example of where getting these 2 solutions and with Cloudy, these 3 solutions to work together provides something that's greater than the sum of its parts. Along the same thread, we have, an integration that we launched a little earlier this year with Instana, where you can see the cost implications, the cost result of your performance changes, things like deployments, patches, changes in infrastructure, right? So being able to look at, application performance data through the lens of cost is something that we think is necessary, but really hasn't been done up until now, and it's an important dimension. So that's the kind of the long explanation. The short one is we're building lots of really cool stuff together, and we think that it's going to help you solve some of the big pains and challenges that you're running into.
Awesome. Thanks, Joe. So we'll go ahead and end the Q&A portion there. I did want to flag to everyone that if you had any additional questions that we couldn't cover today, you're welcome to email us directly, and our email is team-kubecost@ibm.com. So reach out to us there, and we'll get someone from the team that can help answer any specific questions that you have. But we also have our Slack community, so you'll see a link there on your console, but you can also find a link on our website. But if you go there, we have a community of several thousand users, so you can post questions or share tips and insights with other folks that are also using it. And if you're not using Kubecost yet, it's super easy to install. You can also find a link to our install page there on your console. It takes less than 5 minutes to deploy, and you can use the Kubecost free version, or I'm sorry, the Kubecost Foundations version, up to 250 cores, I believe, is the limit today for that free version until it knocks you into gated enterprise features. But play around with it, start figuring out what your environments look like and how you can optimize. And then if you have any questions from there, we're always here to help you out. And with that, thank you to both Joe and Mike, and we hope you all have a good rest of your day. Bye, everyone.
Thank you, everyone.
Thanks, everyone. Y'all's time.